I'll zoom in. So again, if you want to take photographs, but this basically is each chapter and then the content from each chapter. So we're going way back. The good news is you've used a lot of this stuff on repeat, so you should remember it. But in 1, 2, we talked about what's like a congruent segment, congruent angles, all those definitions came out. We talked about the segment addition postulate. If you have 2 parts, you can add them together to get the whole, that kind of thing. And then in 1, 4, we talked about classifying and naming the polygons. They can't have any open sides or any curves, and they have to intersect at exactly 2 other sides at their endpoints. And then we talked about the difference between convex and concave. So these are words that then continued to get built in to other things. So hopefully we know this stuff because you reused it. But anything that you don't know or you need a refresher on, obviously, is something that you either want to write down or take a photo of. Or this is on the video. It's now being recorded. Perimeter, you're adding up all the sides. That was the very beginning of chapter 1. And then the area, we did rectangle, we did triangles. And then 1, 6, we added complementary angles, supplementary angles, adjacent angles, linear pairs, and vertical angles. Complementary are angles that add up to 90, supplementary add up to 180, adjacent are they're next to, they share a side, but they don't overlap. And then a linear pair form a straight angle. The linear pair postulate came later, and that's what said they add up to 180. And the vertical angle theorem came later and said that they are congruent. Okay, those 2 things came after this. This was just identifying what they were. Questions on content for chapter 1. Chapter 2 was where we started all the inductive and deductive reasoning. So we talked about contrapositives, or actually we started with the if-then statements, conditional statements, and then we did the converse, the inverse, the contrapositive. So if you're doing a conditional statement, this is your P, then Q. If P, then Q. What happens when you do the converse? Switch the order. Q, then P. Good. The inverse.
Were we supposed to do this yesterday?
No. The inverse. You negate both. Not P, then not Q. And then the contrapositive, you flip and negate. Not Q, then not P. So this, you could get a question on your test that says, here's the original statement, find the inverse, the converse, the contrapositive, and you're picking it from like your multiple choice. That's how that kind of will show up. You obviously need to know the definition of perpendicular lines, which is that they form the right angle. You need to know inductive and deductive reasoning. So deductive is something based on fact. Inductive was based on a pattern. This is where we started to do proofs, so you need to make sure you know all the properties. The reflexive, the symmetric, the transitive, and the substitution, and then again, be able to identify them. So you'll see these in 2 ways. 1, multiple choice question. 2, built into the proof. So reflexive is anything that equals itself, right? So like AB equals AB, that's reflexive. Symmetric, we switch the order. If AB equals BC, then BC equals AB. Transitive has 3 parts. If, let's say, angle A equals angle B, and angle B equals angle C, then angle A equals angle C. Substitution we saw mostly with values. So if angle A equals angle B, and angle B equals 40 degrees, then angle A equals 40 degrees. So you're taking and plugging the value in on that one. The vertical angles theorem and the linear pair postulate. Okay, we're in here, and then supplements and complements came back again. We had the law of detachment versus the law of syllogism. So law of detachment, if You ask nicely. Your teacher may bump your 89. Okay, so if that's your if-then statement, then the law of detachment, you only have the if occur again. So you ask nicely. And based on that, your conclusion would be what?
You will get the exemption.
Nope. There's no mention of exemption. Teacher bumps the 89. Teacher bumps 89. Now, the law of syllogism puts two if-then statements together. If you ask nicely, then your teacher, God bless you, may bump, your 89 if your teacher bumps your 89, then you are exempt. So then the if-then here is if you ask nicely, then what? No, that would be the law of detachment. Law of detachment is only the if and the then occurring. But the law of syllogism is if and then. So if, then, and then that then repeats, right? You are exempt. Good. So law of detachment, you only get one. I don't even know what that blue dot is. Law of detachment, you only get one if-then statement, and the if occurs. Whereas law of syllogism, you have two if-then statements, and the then on the first becomes the if on the second, and that's kind of what links the two together. All right, chapter 3 was our introduction into perpendicular, parallel, and skew lines. We brought back in slope and equations of lines, so you need to know y minus y1 equals m times x minus x1, and y equals mx plus b. You need to know that vertical lines were x equals a number, no y, and it would have undefined slope. And then horizontal lines are y equals a number with no x, and slope is 0. So this is where some of that algebra stuff came back into play, identifying slope from points, identifying slope from a line, that kind of stuff. Questions on any of that stuff? What's the difference between perpendicular and skew? Yep, Santi. Nick. Good. So the skew is not coplanar. And the perpendicular is coplanar. And this one has a right angle, and this is don't intersect. But on the same plane. So if you're looking at, like they like to give you a box on this kind of question. Okay, AB is going to be perpendicular to something like BF, where those two sides meet. That would be a right angle. AB would be parallel to CD, or AB would be parallel to EF, or AB would be parallel to GH. And then AB would be skew to like DH, something that runs in a different direction on a different plane. And then we talked about parallel planes, like the top and the bottom, the front and the back, the left and the right. Those would be parallel planes, okay? Two planes that don't intersect. You would need to be able to identify that stuff from a diagram. Questions on chapter 3 content? Okay. Also on 3 were your corresponding alternate interior, alternate exterior, and consecutive interior angles. So you need to be able to identify them from the from the picture, just like this is. Or if the lines are parallel, you would need to know that they are all congruent except consecutive interior, right? So these two would be congruent because those are corresponding. These two would be congruent because they're alternate interior. These two would be congruent because they're alternate exterior. These two would be supplementary because they are same side interior, consecutive interior. 13, 14, and 15 are your slopes, so y2 minus y1 over x2 minus x1. And then 16, 17, 18 are the lines if you're given the point and the slope. And then 19, 20, and 21, what if it's perpendicular? So what's true about two lines? What's true about the slopes of lines that are perpendicular? Good. Slopes of perpendicular lines have opposite reciprocals. And slopes of parallel lines? Good. So obviously that's important if you're trying to find the equation of a line and it gives you that kind of information. All right, chapter 5 came classify. So you need to know how to classify based on sides and angles. So sides, you've got equilateral, isosceles, scalene, and then angles, there are 4, acute, right, obtuse, and equiangular. I would need to know equilateral has all 3 sides the same, isosceles 2 or more, and scalene none. And then acute, obviously, based on the angles, all would be acute or less than 90. Right, 1 is equal to 90. Obtuse, 1 is greater than 90. And equiangular, they are all what measure? An equiangular triangle. They're all equal, which means they're all what? Specifically, what measure? 60. If they have to add up to 180, then they would each be 60 degrees. Proving triangles congruent. We had side, side, side. We had side, angle, side. We had angle, side, angle. We had angle, angle, side. And we had hypotenuse, leg. So you could not only see like a diagram where it would say, are these congruent? And if so, why? Or you could see your proof come from that stuff because we had a lot of proofs from that section. CPCT says if the triangles are congruent, then the corresponding parts are congruent. So if I am trying to prove that they're congruent and then I'm trying to get that one pair, like the 2 triangles are congruent, so then one pair of angles are congruent, that's CPCTC. The sum of the angles in a triangle are 180. And then the exterior angle, so if this is exterior angle, the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. All of that happened in chapter 5. Questions on 5? Okay, then chapter 6 had all the bunch of different kinds of information. So there's a lot in this. Chapter 6, 1, we started with the easier stuff, the angle bisector theorem, which said that if a point lies on the angle bisector, it's equidistant from the sides. The converse to that, if a point is equidistant from the sides, then it lies on that angle bisector. The perpendicular bisector theorem, which said if a point lies on the perpendicular bisector, then it's equidistant from the endpoints of the segment. And the converse of that, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector. So that was all 6-1. Then came this guy, which we filled out, I think, twice, which is all 4 of your special segments in a triangle: the perpendicular bisector, the angle bisector, the median, and the altitude. You would need to know what they are. So by definition, perpendicular bisector is perpendicular to the side at the midpoint. Angle bisector bisects the angle. The median goes from the vertex to the midpoint of the opposite side, and the altitude is a perpendicular segment that connects the vertex to the opposite side, or the line containing the opposite side. You'd need to know its special name where they meet, the point of concurrency, because it's going to say the in center of this circle or this triangle is blank. And you would need to know that that means it's the angle bisectors. So circumcenter goes with perpendicular bisector, angle bisector is in center, median is centroid, and altitude is orthocenter. The circumcenter and the orthocenter are the in, on, out ones. Angle bisector and medians meet inside. You'd need to be able to find the coordinates of either the perpendicular bisector, which is going to be on a right triangle, would be at the midpoint of the hypotenuse. You'd need to know how to find the centroid, and that's where you add the 3 points, 3 x's divide by 3, add the 3 y's, divide by 3. And you'd need to know how to find the coordinate of the of the altitudes in a right triangle, which is at the angle itself, at the right angle. And then the 3 theorems, one is based on the circumcenter or the perpendicular bisectors. They are equidistant to the vertex. The angle bisectors would be equidistant from the in-center to the side. And then the medians or the centroid is the 2/3 one, where from the vertex to the point where they meet is 2/3, and then from that point to the side is 1/3. So again, this is one of those that I would say it was a lot of content a long time ago that we don't continue to use a whole bunch. So I would definitely make sure I revisit this stuff. And then came the mid-segment. The mid-segment connects the midpoints of the sides. It's parallel to the third side and half its length. And the triangle inequality theorem, God bless you, said that the sum of any two sides has to be greater than the third side. So if I wanted to know the possible length of a third side, it has to be bigger than the difference but less than the sum. And then the hinge theorem and the hinge theorem converse came from this, where you had 2 triangles, 2 sides were the same, but one was bigger, or what, the angle between them was bigger, and so you could compare that missing side. Questions on 6?
Can you go back to 6-1?
So putting sides or angles in order. Make sure you pay attention to the wording. If it's least to greatest, obviously it's got to go one way. If it's greatest to least, it's got to go the other way. And that would stink to get that question wrong just because you're reading it wrong. 7-1 was all the angles. This should feel like it's a little bit more familiar because we just did this not too long ago. The sum of the interior is n minus 2 times 180. The sum of the exterior is 360. Each interior would be taking that sum, dividing it by n. Each exterior taking the 360, dividing it by n. To find n for an interior angle, you would set whatever's given to you equal to 180 times n minus 2 over n. And to find n for an exterior, you would just do 360 divided by the angle given to you. There was a lot of formulas and it was all in 7-1. Then came the Venn diagram of quadrilaterals, parallelograms, rhombuses, squares, and rectangles. So all quadrilaterals have 4 sides, and the sum of the interior angles is 360. Once we got to parallelograms, we said both pairs of opposite sides are parallel. That's the definition. Both pairs of opposite angles are parallel. That was the parallelogram opposite angles theorem. Diagonals intersect each other or bisect each other. That's the parallelogram diagonals theorem. And opposite sides are congruent, parallelogram opposite sides theorem. The good news is you don't need to know these names. Like, you should be able to tell me what the property is or use the property, but you don't have to know these names. And then consecutive interior angles would be supplementary, and that's the parallelogram consecutive angles theorem. So 5 things we know about parallelograms. Then if it's a rhombus, it got more specific because it has all 4 congruent sides. The diagonals bisect the opposite angles, and the diagonals are perpendicular. If it's a rectangle, there are 4 90-degree angles, and the diagonals are congruent. And then properties of squares is all the things because squares are rhombuses and rectangles. There are 5 ways to prove a quadrilateral is a parallelogram. Prove the opposite angles are congruent. Prove the opposite sides are congruent. Prove the opposite sides are parallel. Prove diagonals bisect each other. And if one pair of opposite sides is both congruent and parallel, that is also enough. Then we got into trapezoids, kites, and the mid-segment of a trapezoid. Trapezoid had one pair of parallel sides. The isosceles trapezoids have congruent legs and congruent base angles, and the diagonals are congruent. Kites have 2 consecutive pairs of congruent sides. The diagonals are congruent, and the angles where the non-congruent sides meet are congruent. And then the mid-segment of a trapezoid hits the trapezoid at its midpoints, hits the legs at its midpoints. It's parallel to both other sides. And to find the measurement of the mid-segment, we do base 1 plus base 2 divided by 2. Questions on any of it? So again, it's 47 questions. I forget how many are multiple choice. There's a good amount of them are multiple choice, and then there's some open-ended, and then there's 2 proofs. One partially filled in, and then one that's going to be empty. Mars.
You do something like this where you have to find the other side given the...
So if you're given, which one? Like you're given the base, and let me see what you got there. Like this,
Like
this.
Or the top one and the mid-segment are given.
Okay, so an expression or like a number? An expression. What is it, 11 plus x?
No, it's 11.5 and 18.7.
This one?
Yeah.
So this is the bigger side, right? There's 2 ways to do it. One is x plus 11.5 divided by 2 equals 18.7. But I think that's complicated. The other way to do it is just find the distance or the difference between these 2 and then add it to the 18.7. So 18.7 minus 11.5 is 7.2. And then just add that on and you get 35.9. If it was the smaller side missing, you still want to find the difference between them, but then you want to subtract it.
Isn't it 29.9?
Yes. Wait. 25.9. 25.9? Yeah. Any other questions? Okay.